Hello, good evening, good afternoon. My name is Hoshi Kim. I'm a Vice President and Fellow at SK Hynix, Memory Systems Research. So AI, everyone's talking about AI. AI is a thing these days. And this AI has taken a big hit in a traditional memory company like us. So generative AI has taken the world by storm with its capability to generate content like humans. Many of these generative AI tools are powered by large language model. Many of these generative AI tools are powered by large language model like OpenAI's OpenAI ChatGPT, Llama, Gemini, and also these large language models are very extremely compute intensive. So they can be only run by a special hardware accelerator like GPUs from NVIDIA, AMD, and some of TPUs and inferentials and things like that from many other data centers and startup companies. Then why does someone from a traditional memory company want to stand up and then talk about AI in front of this bunch of AI startup entrepreneurs and investors? Because it's because memory technology has become very relevant for the innovation of generative AI. Today, I'm going to talk about why this is true and why memory technology has become so important and critical in enabling both software and hardware for generative AI. So you probably have heard about recent surge in demand for HBM. It's like news about latest status of NVIDIA's qualification status about a certain HBM provider makes a relevant company stock price up and down heavily. And HBM is a very special 3D stacked DRAM memory which can provide ultra high bandwidth data transfer. They are integrated and packaged together with GPUs in a single package. So we all know GPU is crucial for training and inferencing LLM, but why has HBM become so important in AI hardware? Why is there so much demand for HBM suddenly? GPUs are hard to get, but HBMs are even more difficult to procure from a chip company these days. In fact, not just for GPUs, every AI accelerator company wants to get more HBMs. Why? Can't we use a different type of memory device? I'll tell you about this today. Today's large language models are based on an architecture called transformer. I think this transformer-based large language model trends will continue for a while. Transformer is dominated by massive memory-intensive matrix multiplication. What it means by memory-intensive or memory-bound operation is, no matter how quickly CPU completes its computation, since computation requires so much demand from memory, we can't even complete the entire computation faster because of the performance bottleneck at the memory interface between CPU and memory devices. This is a typical characteristics and limitation of modern computer architecture model called von Neumann architecture, which was invented like 1940s. So in order to accelerate the matrix multiplication in transformer model by massive parallelism, we need GPUs and to ease the memory bottleneck, we need HBM, high bandwidth memory. You probably have heard that tens of thousands of GPUs are needed for training large language model. In fact, the reason why so many GPUs are needed isn't because lack of GPU cores, but rather shortage of HBM memory attached to GPUs. This is known issue called memory wall. To perform massive matrix multiplication on GPUs, the enormous amount of model parameters need to be loaded into memory. However, there's a limit to the number of HBM that can be attached to a single GPU. To secure more memory spaces, you need to buy more GPUs. In other words, more HBMs are needed, which leads to buying additional GPUs that end up being underutilized. In practice, only about half their capacity is used at best. Furthermore, scaling out GPU doesn't actually scale the performance due to the communication overhead between GPUs. Therefore, the amount of HBM that can be connected to a single GPU needs to be increased. There are a lot of efforts in this industry, from software algorithm to chips and hardware infrastructure, to make this LLM computation more lighter and more cost-effective. Most of innovations are actually about alleviating and lightening the demand for high bandwidth memory capacity from HBM. However, no matter what they do, as long as the technology is based on transform architecture, it may lighten the demand for memory bandwidth to some degree, but the nature of this attention-based algorithm never changes. How about inference serving? People are talking about inference serving is relatively easier than training, meaning that it might not need that mighty GPUs. However, it still needs HBM because inferencing is even more memory intensive than training. Text generation for LLM inference serving contains two phases of token generation. First, prompt summarization phase to fill first prompt summarization phase of prefill to understand the input context or prompt from human. Second, token generation phase or decoding to generate a response, text one at a time in an autoregressive manner. One of the main challenges of LLM is supporting longer context lengths, also known as a sequence length. Longer context lengths generally translate into higher quality in responses. However, long context lengths are very memory intensive. The key value cache size grows linearly with the context length, thus putting higher pressure on the memory bandwidth and memory capacity, and consequently slowing down the already memory-bound algorithm, already memory-bound attention decoding. Moreover, since the memory capacity is limited, the batch size reduces when the KB cache gets bigger, which is generally reduced in a drop in throughput. By the way, GPU utilization is very low during token generation. In order to increase this precious GPU utilization and throughput, continuous multi-batching is used. However, multi-batching puts even more higher pressure on memory bandwidth and capacity because it increases the key value cache sizes. So actually, the GPU utilization increase and then throughput increase is limited by memory capacity. The transformer is a very memory-bound problem, which means that the performance of the LLM will be bounded by the bandwidth and capacity of the memory. Larger models of the matrix needs to be larger model needs a higher performance, a higher capacity memory for faster training. And the longer context also requires a higher bandwidth and higher capacity for even more higher quality responses. And multi-batching require even higher bandwidth also for better performance and better utilization of GPUs. Overall, higher bandwidth and higher capacity memory will make this LLM more cost-effective and commercially feasible. That is why this extremely high bandwidth memory called HBM is so important ingredient in software and hardware for generative AI technology. So all the ecosystem partners, including software algorithm, chips, and hardware, needs to collaborate together with the memory technology provider to advance and innovate the future of AI. Thank you.